Morning, everybody, to office hours, coming at you from the Kansas City area with two of my colleagues, Jim Weitzcover, which I met over on the WW Talk in 1992. We looked that up this week. And Christine Lever-Weber, who I don't remember exactly the date we met, but you've got some interesting stuff about pre-scheme.
Yeah, I think we met in the E-Rights IRC channel, the very obscure IRC channel that talked about the E-programming language and related OCAP stuff.
Yes.
Yeah, so I work on OCAP stuff also. I'm actually CTO of the Sprightly Institute. This is not me officially appearing on part of the Sprightly Institute. My co-founder does not even know I'm showing up on this thing, would not approve since I'm supposed to be going on vacation. And I've already been getting plenty of shit for doing work adjacent things. And so but I can't resist, since I'm currently interested in pre-scheme state, talking with other people who might be interested in talking about it as well. So and I just get some stuff ready over here and then share my Emacs. So let's see here. Share.
There was a scheme implementation called Scheme 48, named because it was built in 48 hours. And the first stage of it is this pre-scheme stuff.
That's right. So Scheme 48, pretty cool language. It's the idea, and so I've got what motivated me is I wrote up this little blog post called Guile Steele, a proposal for a systems Lisp, which is kind of what has been getting me to look at pre-scheme recently. And then pre-scheme is this basically to bootstrap Scheme 48. It was this language that was, a kind of systems programming language is kind of a bullshit term, because what the heck does it mean? But, we'll use that anyway to kind of mean the type of thing that you might use to bootstrap a runtime environment in a non-tagged architecture language. You might do some memory unsafe things. You might not. It might be statically typed. It might not. In this case, pre-scheme, unlike normal vanilla scheme, is statically typed. And the cool thing is it can compile to scheme, but it can also compile to other things. So it could it's an abstract language that can compile to multiple low-level targets.
Did you mean scheme or C there?
Sorry, it can compile to C and scheme.
Okay.
So it has a C environment where you can do live development, and it can compile to C. So so the idea is that you had first of all, it allows you to avoid a Thompson attack type situation, right? Because you can bootstrap it in multiple paths. There's a common Lisp version of pre-scheme. There's a version that actually runs inside of scheme. There's the, and other things like that. So you can actually run it in multiple things, get the same output, verify you don't have a, so if you're not familiar with, it was Ken Thompson, I think, right? With the reflections on trusting trust, he gives this paper where he says, oh shit, like you can have a compiler that has an attack in it, and then you can use that to insert the attack into another compiler. Well, that's one reason you might want something like pre-scheme. You can get around your that to some degree. You'd also need, if you're going to compile with eventually the C version, you're still going to also need a C thing that doesn't have that problem too. But basically, bootstrapping things is important for all sorts of reasons. It's also just nice to not program things in C and stuff like that. And these days, of course, Rust is all the rage. But what's kind of cool is that this is a language that has a lot of the semantics of scheme, but it is it's statically typed. It is not garbage collected, and some other interesting things. So in this paper, basically they actually they have the and it has some features that C lacks, right? It's got proper tail call elimination, tail call recursion, which is actually how you do all the looping, which basically means if you're at the end of a procedure and you're going and that procedure doesn't have any more work to do, it doesn't take up any more stack space, right? It gets eliminated from that. And if it's actually jumping back to itself, it in fact doesn't even need to call a new procedure. It can actually just perform a very trivial jump, and it's highly efficient, right? And it's got all sorts of other nice things. And you can do live development of it, right? So Lisp developers love that they can Hackett stuff at the REPL. Kind of C is not a good environment for that. I mean, you've got GDB and you've got other things like that, but it's not a nice place for you to kind of build up your C expression that you're just going to paste into your language the way that you would in Python, JavaScript, or Lisp or whatever, right? So, and the other impressive thing is that pre-scheme exists since the 80s, right? And it uses Hindley-Milner, which is like for its type like a modified version of Hindley-Milner, which is what Haskell and other things like that use, so that you don't have to do stuff like in like if you ever were doing static type checking in Java, it's like a pain in the butt. You've got to like annotate every little detail, right? You don't have to do that when you've got something like Hindley-Milner. And in fact, it looks very, very, very the type of stuff that you're writing. You're pretty much not having to really mark everything with like what type of type it is. It's able to infer a whole lot of things. So this is what Scheme 48 would use to bootstrap its garbage collector, the virtual machine, all sorts of other things. But you could also use it to just write other kinds of C-like programs and stuff like that, right? There's no reason you can't use pre-scheme much more generally. And here's some example of like compiler output for pre-scheme. So I think this is pretty neat. Yeah, and then here's some, assembly code for what it does, et cetera, right? So I think it's pretty neat. The other interesting thing is that there's another paper which is called a verified compiler for pure pre-scheme. Actually comes out before the other paper that I was just showing. In 1991, this paper comes out, and it's about VLisp, which is a verified Lisp. So this is a verified compiler for pure pre-scheme, which is then used to make a verified Lisp that then compiled onto the, I forget which one it was. It was like the Motorola, which was it? Motorola something or other processor. And they were able to verify the whole Lisp and stuff like that, which would have been, hard to do in some other languages. And like these days, verification and everything like that's all the range. But this other paper came out in 1991. It's pretty freaking cool. So what I'm interested in, I don't want to write C, and I actually don't want to write Rust either. Cool languages, in many ways. Rust's package system, a nightmare. Kind of like Node NPM's package system, it's a nightmare, but not quite as bad as that. And so I would, and I'm also part of the Guile and Geese community, and I also just think it would be fun to have our own systems language type thing. So that's what motivated me to write up my Guile Steel proposal type thing, which was partly, me hoping to trick other people into painting this fence along with me, which is happening because, there's the Andrew Watson started porting over to Guile the pre-scheme code. Now, I don't think pre-scheme is actually where we want to end with things, because one of the things about pre-scheme is that it's still it's not garbage collected, and its memory management situation is not as nice as like Rust's, right? So Rust has done a lot of innovations around shared memory and stuff like that, and having memory safety without having to explicitly deallocate. And I think that's great. And I would like to see those types of ideas brought over here. I also think that we can actually do better than Hindley-Milner for the typing stuff. I gave a talk over at MetaMask recently about propagators, why I think they're really interesting. In Alexei Radul's dissertation, he shows off.
Can you make sure you drop in the pointer to that MetaMask talk?
Yeah, I can do that. I'll put it in the chat right now. So hold on. Brainy, Sprightly, propagators, Brainly, and Sprightly. Yeah, it was really well received. People really liked it. I show off a live demonstration of my propagators implementation, which is incomplete, but it does enough for me to be able to show off cool things, how it's able to solve problems from multiple directions. It embraces incomplete information and kind of narrowing things. And it's a yeah. What's that? Sorry, I missed that.
I might have already seen it after all, but it is pretty cool. Meanwhile, I'm going to stick 2 questions in. One is anybody compiling pre-scheme to WebAssembly? And 2, any thoughts on compiling Jessie to pre-scheme?
I think so. First of all, oh, okay. So these are 2 things, right? So one is so we'll come back to propagators in a moment, right? So and actually, I'll just stop screen sharing and hand wave dramatically for a moment, right? So okay, no longer sharing, hand waving dramatically, right? So the your questions were, could you compile the WebAssembly, right? So there's no reason you couldn't compile the WebAssembly, right? Pre-schemes, semantics are abstract higher level. Guile has this nice thing called the compiler tower. A number of languages have something like a compiler tower, but it's actual feature in the language that you can use. So you can actually add. I mentored a Summer of Code project that would compile Scheme to JavaScript. Didn't get merged into Guile properly, but it was a fun project. I'd still like to see it get merged. You can also have Emacs Lisp that then compiles to Guile's virtual machine, and you can also have JavaScript at the top or whatever. So what I'd like to see is a pre-scheme or whatever we end up having type thing inside of Guile at a high level thing where we can write these kind of lower level code and then have it compile down to multiple things. One of them can be either, you could take the C path as your kind of cheat approach and then compile the WebAssembly and then compile to whatever your compiler target is, including WebAssembly. Or we could add stuff so that you can compile directly to, assembly directly in the thing. Or you could compile to one of the intermediate languages of GCC or LLVM. But you could also just compile the WebAssembly directly. And so one of the conversations that's happening right now in the Guile community is how are we going to compile the WebAssembly, which I think is really important for the success of the language. And now you asked about Jessie, right? So Jessie is Agoric's initiative for a safe subset of JavaScript. Well, actually, I think it's the Endo initiative, which Agoric is kind of a lot of leadership in that. And so it's a safe subset of JavaScript, right? So sure, if you wanted to write a secure version of Jessie, right, that didn't have these kind of vulnerabilities, one path to that is that you could write the Jessie compiler in pre-scheme, right? Another path is we could, if we had a general purpose virtual machine for something like that written in Guile, and on top of pre-scheme, you could also add a top level version of Jessie that compiles to Guile's other intermediate languages, and then actually just have Jessie as the top level thing that actually just compiles onto the same virtual machine that we have for Guile. That's actually the direction I'd prefer, but you could use it to build a separate Jessie specific compiler. You could also do the terrible thing of compile pre-scheme directly to Jessie and have a very inefficient version of things that run in JavaScript properly. But that probably is inadvisable when you could just compile the WebAssembly or whatever.
Now you're talking asteroids in VI macros.
Right, yeah. Anyway, so I guess that's my morning rant on pre-scheme and stuff like that. The only other thing I didn't talk about was the reason why I think propagation networks are really interesting for static type stuff. I could ramble about that for a minute if you're interested, or we could just shut this down, I guess, for the Christine's rambling.
Whoa, 2 of me.
Mm-hmm.
You can go for a little bit more.
Okay. Well, I'll screen share again. So this is Alexei Radul's dissertation on propagation networks. It's really interesting. I recommend that everyone read it. Propagation networks, a flexible expressive substrate for computation. It's one of those papers that you're reading it, or basically a book because it's a dissertation, where like I read it like it was like a gripping novel to me. Like I would read it and I was like, oh my god, I can't wait for the next page, right? Like it's that exciting for me personally, at least. Like you can read. Actually, I want to read the opening paragraph here. In this dissertation, I propose a shift in the foundations of computation. Modern programming systems are not expressive enough. The traditional image of a single computer has global effects of large memory is too restrictive. Okay, actually, I'm not going to read that whole thing. But basically, he calls for what we want is like a revolution in programming. And so he presents propagators, which have been around since the 70s or 80s, as something that like Sussman students have been experimenting on, starting with Richard Stallman, actually, on the first propagators implementation. And there's all sorts of interesting stuff that I go into in the talk that I gave at MetaMask. But here's the part that I really want to talk about right here. Let's get to the part where it says expressive power. And expressive power talks about how, look at all the types of things that propagators are the proper generalization of, right? Dependency directed backtracking. Okay, that's not too surprising if you know a bit about propagators. Probabilistic programming. Oh, that's pretty interesting. Constraint satisfaction. Well, that's actually, I mean, propagators kind of are a constraint solver system. Okay. Logic programming remains mysterious. Yes, logic programming is a mystery. It gets into spooking type areas, but it can do logic programming just fine. Functional reactive programming. Oh, okay, great. Rule-based systems. Type inference. Oh, interesting. And propagators are actually a really powerful generalization of all these types of things. And what I'd really like to see, so I actually would encourage you to watch the paper I give, or the presentation I give, because what I think is these ideas could be combined with the type of things that have been done with mini-counter and stuff like that, where we could actually really do the full Lisp dream of programs that write programs, but actually have programs that you can put a hole in your program and you write your unit tests and it just actually finishes writing your program for you. It says, oh, actually this piece of code, it could complete it, and it can have a completion, but not through some neural network doing it, but actually through logical deductive reasoning and stuff like that. So propagators can do all sorts of really interesting things. Especially if you combine them with some of the interesting things that the logic programming world's been doing for code generation. And if you combine them with, there's a section in here when it talks about type inference, it looks like propagation too, basically shows there's some interesting papers that talk about, like things like Kinley-Milner basically are constraint solvers. And propagators are like the world's most powerful, most interesting constraint solvers, which also embrace interesting things like partial information. So I think if we were going to do a modern, and even my understanding, I don't actually know too much of it, but of Russ's borrow checker thing is that it actually uses constraint solving type approaches to be able to solve all that stuff. So I actually think that if we did a propagator type approach and then like said, okay, what if we took pre-scheme and then we did a propagation type approach and then started layering some memory management type stuff like Rust and stuff like that. That's basically the vision of what I really want to see for Guile Steele. And by the way, Guile Steele, you may notice, is a clever pun. If you listen to me saying it out loud, what does it sound like? Guy L. Steele, right? One of the co-authors of Scheme. Anyway, that's it. I'll stop sharing again.
So I want to springboard. That was cool. And for my video editing resource, Mark, I want to springboard off the functional reactive programming and OCAPS. And
my propagators implementation runs on top of Goblins, by the way.
Can you define simply propagator?
Sure. Sure. Actually, why don't I do it visually? They're pretty easy to understand. But actually, why don't we let Dan finish speaking and then I'll show.
Well, you should answer that question first, but only if you can actually do a definition and not an example.
Sure, I can do a definition both visually and also as in terms of I will try to do one out loud.
Okay. That is not just an example.
Yeah. So let me. So propagation networks, propagators, are systems that have two components. They have cells that carry data, and they have little machines in between that are propagators that do computations. So, and the network runs until it hits a fixed point. So, and they're fully asynchronous. So they work well with an actors type approach. And they eventually settle on a value until they get new inputs. They also do not permit contradictions. So propagator networks, that's my best explanation. It's not a
Okay.
short definition because I don't have a short definition offhand. But now with that in place, what's that?
That's
okay.
sufficient.
Good. So with that in place,
yeah, that's sufficient.
So with that in place, here's the Fahrenheit to Celsius converter. And if you look at you'll see this more if you look at the presentation I give at MetaMask. But, okay, so Fahrenheit, you can put in Fahrenheit on this side. And then this is a cell, right, for Fahrenheit. And then this is a cell for 32. This is a cell for 5. This is a cell for 9. And then there's intermediate cells for, and then these are the propagators. So this is a propagator for minus, a propagator for times, a propagator for divide. So these cells are feeding in information and receiving information. And the propagators are performing computation. Now, this propagator right here is a constant propagator. So it's going to feed always the number 32 into this cell 32, right? So that cell's always going to end up with the value 32, right? Now, this propagator for 5 is going to always feed in the value 5 here, right? And this propagator for 9 is always going to feed in the value 9, right? So if we put in something for Fahrenheit here, we put in, some number, then this is going to do that number minus 32, and then that gets outputted to F minus 32, okay? And then that can therefore, so what happens is that these cells this cell would first input this thing to the propagator and it would say, hey, I've got this thing. And this would try to do a computation and it says, well, I don't have enough information with just one value to do anything interesting. So it doesn't spit anything new out to these other cells. But once this thing comes in with the Fahrenheit, it says, oh, I've got enough information, and it spits out here to this guy, oh, okay, here's enough information where we've got an output, right? So that
I think it's pretty clear. Our homework assignment is to write this in Rolang.
Right. So, but the interesting thing is you can now do it in reverse. You could feed in the thing for Celsius, and it will actually do it in reverse, and then get the thing to Fahrenheit. But the other interesting thing is, if you give Fahrenheit and Celsius, but you don't provide 5, it'll solve for the constant 5.
Sure.
Right. So it can solve for any part of the equation. Right. And I show that off in my my talk. But that's just the beginning of what's interesting about propagators. The other interesting parts about propagators show up in the talk, and that the big innovation that Alexei Radul provides is partial information. And the way that truth maintenance systems come in and allow for the system to try to solve things from multiple perspectives. And I won't get into that here because you can watch my other talk to actually hear about that. But yeah, they're basically constraint satisfaction networks that just have the idea of cells and propagators. And the cells inform the propagators when they have new things. Propagators are stateless. They do not contain any state. They just run whenever they receive information from a cell. And then that propagator will send stuff out to the remaining cells, and cells will only notify their attached propagators if they come to a new value, right? And they can only move from no information to complete information, but there can be intermediate states, right? So you might know part of your information about a value, and you can narrow down to a complete piece of information, but you can't actually have contradictory information that will signal an error in the propagator network. So it'll detect when you're being inconsistent.
Interesting.
Very sweet. So maybe we should try to get some Rolang experts to try to work through translation, if it's possible, to Rolang.
Could be. Yeah, that'd be good. All right. Okay. So that was my propagators part. Anything else? Dan, did you have your thing that you wanted to say, or?
Yeah.
Oh, this Tony stuff. Yeah, I'm a fan. Tony and I are friends.
Right. So, there's a bunch of cool technology underneath this that I've looked at it once or twice before, but it runs on a phone. It actually boots the phone. I don't know what it does after you boot.
So can I actually talk about this a little bit? Because Tony's not here, but I know, and Tony and I have calls every now and then, and we've been talking about our stuff.
Well, if you tell me what it does after you boot.
Well, I don't know what it's specifically doing here after it boots. He's got some phone applications on there, right? You can.
Right, that's what. Okay, so this is what it does after it boots.
But
The interesting thing about this to me is that it's actually an OCAP system that does this much
That's
stuff.
right. So, and it's
a modern device.
It's become more OCAP-y over time, in partly also in response to him and I talking, right? So he was interested in OCAPS, but Syndicate and Goblins have influenced each other. So we've had calls with each other, and they've become closer to adopting each other's ideas over time. So Syndicate is an actors type system, which instead has these areas where there's like where there's shared information, basically.
Which is kind of like the what's the space called in the Erlang virtual machine? No, this is a question to Jim. R space, right?
Mm-hmm. So originally, so one of the big changes. So Tony and I's work have shot back and forth, and actually with OCAPN, the whole syrup thing, that's actually based off of Preserves, which is Tony Garnock-Jones and I's conversation. Right. Like that's Tony's thing that happened from him and I talking about how much we hated all serialization systems and how canonical S expressions were the starting point, and then it eventually ended up with Preserves. But anyway, Syndicate.
Well, hold on. Let me drive just a little bit here. So you can clearly talk between a system like this and a Goblin system. What about running Goblins on this machine?
So that's the part where we need to get more consensus between us and Tony. Is that I want Tony's thing to actually speak OCAPN. It's not currently. And I think,
well, but that would be communication between this thing and Goblins. But what if you wanted to run Goblins on this, they'd have to either share a virtual machine or have two virtual machines running at the same time, which is a little bit boring.
No, so I don't think that that's the case. So because what I actually think
you don't think they have to have two, or that the two is boring. So
let me explain where. So it's become closer to what I'm proposing over time. One of the things that I pushed on Tony at one point, and Tony's pushed a lot of things on me, like as I said, we've both influenced each other. But one of the things I pushed on Tony is I said, I actually don't think that this version of things with Syndicate is the abstract low-level piece that you like. It's like the lower level of things. You actually want a generalized object-y version where Syndicate's abstractions are built on top of that. So Syndicate now builds on top of something that's closer to E or Goblins. So that is now an abstraction layer above it. And I actually think that Syndicate should just be built on top of Goblins. So if Syndicate was an abstraction layer above Goblins, then yes, they would absolutely be talking to each other, and you'd get CapTP for free. So that's actually an argument I'm trying to make. That's not currently, Tony is not currently sold on that. And so currently, Tony is reinventing CapTP, has studied CapTP and making a different version of it that has special primitives just for the tuple space stuff. And I actually am arguing to him that no, you should just have the low-level E-level thing that Syndicate is already using, be the generalization there, and then have special Syndicate actors that are sitting on top of there that are part of the protocol. So that's something for him and I to talk about. And so I guess I'm having that debate and argument with him without him being here and without him being able to defend himself. Sure. But Syndicate's super interesting. It's Tony is definitely one of the people that I think mostly highly of in the programming world. And what's really cool is that what Tony has managed to do, which I have not managed to do, is have a very large variety of programming languages running his stuff. So it's running on Squeak, but it's also running on top of JavaScript, and it's also running on top of Racket, and it's also running on top of Haskell, I think. So like his stuff's pretty cool. And they can all speak to each other.
Do you know what it uses for the pre-scheme level?
Well, this one's just running on top of Squeak. So I think it's just metacircular on top of Squeak, I think, but I don't know for sure.
And Squeak is compiled to the ARM processor?
Squeak is a Smalltalk environment.
Yes, but something has to actually have machine instructions.
That's right. So I think that's what's happening. Squeak is running on top of ARM. And okay. So it's using Squeak as a runtime environment. That's my understanding. Tony should show up to one of these calls if I'm wrong.
It's just asynchronous object calls, right?
Say again?
Just asynchronous object calls, the same as our distributed Smalltalk at NJIT.
Mm-hmm. Yeah, it's got synchronous too, but there's definitely an asynchronous. There's the actor model stuff to it. Yeah. Okay, so how does There,
Yeah.
where's ARM? There we go. Linux or ARM v8. Look at that. Blammo.
I put in a request, another request for our source code. You know, ours was totally asynchronous. Except if there was a local object, that's true.
Right. Yeah, when you're dividing 5 by 3,
would get down to it would actually do it.
Good old Byte Magazine, 1981.
Yeah, look at that. Look at that hot air balloon. It's fun to show up. Anything else you want to talk about before I hop off of here? I mean, you all can keep talking about Syndicate and everything if you want to, but I actually should probably hop off.
Let's just do this real quick. How do we get to Sprightly?
Oh, go to sprightly.institute, because that's where the if you look at the top, actually right there, actually you can just click right at the there. Current developments happening over the Sprightly Institute. So this is a big thing. So that we're spinning up this nonprofit, and that's where a lot of new things are happening, right? So the word object.
Okay, so scheme primers the headlines these days. All right, got it.
Yeah. Yeah. So we're getting.
Watch this one yet.
Yeah, we're getting things up and running. It's fun, I think. I'll be interested in your thoughts. Anyway, I gotta go.
All right.
Nice talking with you all.
Thank you so much. It's great to have you again.
Yeah, thank you. It was fun. Let me know when the recording's up. Bye.
Okay. So,
you know, Greg's been.
You're on. You're recording, by the way.
Greg has been suggesting that we can do propagator type things with Rolang.
Oh, okay, yeah.
And I'm not sure I completely grokked how that works, which would be really interesting.
It looks fairly straightforward.
Yeah. Yeah, I guess we just have to think out the problem.
Mm-hmm.
But you know, I guess I'm thinking more of a almost mechanical type translation.
Well, I don't think propagators is a language. I think it's a pattern.
Right. It's a pattern, you know, I mean, basically, if we take the definition of the converter and we make that Rolang, I think that would demonstrate it nicely.
Yeah. He said each propagator doesn't have any state, except that he said it only sends out new signals if its state changes, if its value changes. Oops, that seems like state to me. Anyway. Then note to the video editor, I'm going to do something. It's not published. This. Jim pointed out a hole in my memory this week. This is some work on ancient browsers. I have special glasses that are tuned to just the right distance. And there's evidence to show that I worked on a browser. And unfortunately, I'm pretty sure I lost the files. But I know that I did this so my normal blog, and then work on HTML web architecture, and where's the did I? Yeah. So in 1992, I guess it was, I did a rich text widget And I found some mail, like messages to my supervisor and stuff like that, that shows that basically what I did was I converted HTML to RTF and I stuck it into this widget. And I had some TCL code that powered it. So it wasn't all that interesting.
So you should probably contact the guy who's doing this archive. I guess there's a contact there. Or I can just give him.
No, I should contact him. Yeah. What does he say? Mm-hmm. So that's Tweety at 9p.sdf.org or tweety@sdf.org. What is sdf.org? Wow.
I mean, he's associated with the university. Maybe I'll forward you the email. The full, I asked him to request an email that I could forward to NJIT.
There it is, Super Dimension Fortress. I was wondering what SDF stood for.
Super Dimension?
That's what it says, Super Dimension Fortress. My fonts are too small since I switched to this machine. I might have to make myself an account here.
What is it?
The Super Dimension Fortress is a network community of free software authors, teachers, librarians, students, researchers, hobbyists, computer enthusiasts, the oral and visually impaired. I think I'm all of those, maybe not all impaired.
Interesting.
Yeah, I'm struggling with backups this week because I'm migrating from one machine to another. Maybe I would use this for backups.
I had to set up backups for 2 Cloud instances that I'm running for Digital Life Collective and CoCloud, which I get, that's what we're using for our dev. Though we haven't been using the Cloudron lately.
Trying to figure out how much space do you get if you make an account here.
Public access Unix system. So I wonder why they
disquoted 20 megabytes. You were wondering?
No, I'm getting people confused. I have this group, Drutopia, on CoCloud. I mean, they're on the shared server, but never mind. But that's shared internet type thing, or public shared access is something that I've been trying to do on, in a decentralized way, trust network, where we run our own stuff. I just got a new sysadmin for CoCloud.
Yeah, that's kind of a tension, if not a contradiction in terms. We run our own stuff, but we have a sysadmin, right?
Well, I mean, basically he's going to make recommendations about what to do, and then hopefully people will do it. But, he's one of the users, and he's pretty much a security stickler.
Mm-hmm.
And we need somebody like that on the team in order
to security. you know, running your own machine is sort of not consumer technology. So it's kind of like a house in a way. Yes, you can live with one person in a house, but it's a lot more economical to have 5 or 8 people in a house, you know, so that they can share the risk of a toilet breaking and all that kind of stuff.
Yeah. You know, the sort of like everybody has different skills, and we can't assume that, you know,
right,
in a group of people, somebody is administration skills or whatever. And
everybody are. So
each person.
I found via the Tweety ancient browsers thing, the UCalgary archives are better than the Web Consortium's archives. Well, they have different stuff. I discovered that you introduced the pre-tag.
Yes. Actually, Alan Lurch suggested it, and everybody agreed it was a good idea. And
well, as far as the public internet is concerned, you introduced it, right? I mean, he might have been your colleague at NGIT, right?
Yeah, well, actually, he was at that time. No, what was he? Well, way back when in IS1, Al was my boss, sort of. But at that point, we were just co-workers, and you know, I introduced the browser, and with the enhancement, the pre-code, and you know, immediately we could put everything up with length. So, you know, the man pages look beautiful, and all the content on the internet was, you know, what was fixed was great. And but Mark Anderson came back and said it was a great idea.
This is the first occurrence of that tag on the internet. Jim, this is the first occurrence of that tag on the internet, right?
Oh, yeah.
Okay.
Although, you know, I think, you know, I don't know what happened to my earlier messages. And like I was saying before, I think I kept hitting the lowercase r instead of the capital R, replying to people.
I see.
And so it didn't get recorded. But, you know, by, you know, what was it, November 1992, we had completed the work on the W3 browser and our experimental server. And the experimental server had database interfaces. We had a crawler into a Z's, what is it, 7950 database.
Right.
Search engine.
Right.
We had, but you know, it was, you know, basic idea was, you know, exposing these, that the web could do much more than just hypertext.
Well, or people's definition of hypertext should be expanded.
Yeah, well, interactive hypertext in a sense. Or applications, not, you know, applications, not just hypertext.
Well, I would maintain that all the stuff we're doing right now is hypertext. So,
yeah, but it's applications. Okay, right. If you go back to the original,
right, it's not just literary works.
Right. We exposed the W3 browser on the public packet switch networks. So we had like 2,000 people from all kinds of organizations on eyes that had the opportunity to try it. I mean, people like Alvin Toffler and Stuart Brand and lots of people. And, you know, a lot of people didn't have ARPANET access. They couldn't really access the web. But this public on the public packet switch networks, they could connect to it, and they got the screen-oriented browser where they could select with the cursor keys.
This is the right
link.
Stuart Brand? From the well?
Yes.
Okay.
Yeah, they published the first issue of the Whole Earth catalog on our system, EYES system. And the well spun off from EYES. Probably mostly because EYES couldn't scale and the performance got to be pretty bad. EYES 1, that's why we were building EYES 2, which unfortunately ran out of money. But I'm hoping to get at least the source code for our distributed Smalltalk, because that was a really great innovation and, you know, a good basis for, you know, a distributed object store that was totally transparent where the object was. If you said X plus Y, X could be one place, Y could be someplace else, and if that is set to Z, Z could be in a third place. So the programmer, you program concepts, you don't have to know where your objects are.
Mm-hmm.
I haven't heard anything yet from NGIT, but I'm hoping they release that source. At the time, there were people really anal because we were funded by AT&T and IBM that this wasn't public. So when I released W3, I really had to release only the binary.
Oh, okay.
And that was ultimately its downfall.
Right.
Because, you know, basically, that wasn't my main responsibility at NJIT, and I was trying to run the virtual classroom and controlled experiments and all kinds of other things.
Right.
And, you know, we really needed the open source community to chip in there. And, well, that's water under the bridge. You had a copyright problem also, right?
I saw in my mail, it said some have an agreement to release the source, like the shape of the code. It was like, you know, it was part of this AVS thing. And so I didn't have it packaged so that you could use it, you know, without the rest of AVS, which was a, you know, hundreds of thousands of dollars scientific piece of software. So it was a matter of the time to package it in a way that would be useful without the rest of it, I think, but I'm not sure. It'd be nifty if I could find the files.
Yeah. So, I've been talking to and some of the other FedWiki people. You're at all familiar with FedWiki, but
yeah, we've talked about it a couple
you might want to
ago.
get into that a little bit when we're done with this.
We talked about that.
Okay.
Go. I probably should get into system administration. I've got my office is in this weird state that's kind of a pain. the node in my wiki when I used to maintain a wiki was called confidentiality versus availability. There's, you know, for stuff that I can just stick. I don't want to blast all over the internet, and those are a real pain to manage. Oh, I can just, if you're interested, I can just show the blog item. Just have to use Google. Yeah. Right. So these are my availability and mass media. All right. So this is system administration crud. And I'm between machines where I'm hitting another episode of availability versus confidentiality. So I've got sort of categories of stuff. Commons is for Creative Commons and open source stuff. There's no constraints. I don't have to worry about who sees it or copies it, and it remains available if I delete my copy. Then there's mass media for popular music, DVR storage, etc. I don't have license to share this stuff freely, but availability isn't a big deal. If I lose my copy, I can easily get another, perhaps not for free. And then there's photos, which are large, and much of it is confidential and original. And then there's some stuff that's confidential and original and not large, like configuration and passwords and stuff like that. So my life has been a search for a solution to these constraints. So I'm at it again. I was going to do a certain synchronization thing that has to have passwords to a Google account in order to update a spreadsheet and stuff like that. And it only worked on my machine, and I was trying to move it to the other machine. And so I was going to do a backup of my home directory, and then which I've got a monitor, but I can only plug it into one machine or the other. And then the network connection doesn't reach over to here, and blah, 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 blah. There's a bunch of these constraints. That's kind of a pain. So that's where I'm at.
So sounds like a propagator network.
If only. Yeah. Yeah. Meanwhile, I'm really tempted to try out this that phone thing. Oh, this is what bits are only on that machine. That was in a private GitHub repository of mine. And then here's my bandwidth research, where it's like, okay, I bought this thing that says 120 megabytes a second, but when I measure it, it's actually 22 megabytes a second. Boring. That was the backup I did. It took 3 hours. Oh, where was that phone thing? There's a request one build thing that I was trying to run. Oh yeah, this is the one.
You put it in. Put it in.
Did I not already put it in?
You're going to load it into a phone, huh?
Yeah.
I guess you could use a phone emulator.
No, I have actual hardware. You know, I have an old phone. Although, yeah, maybe an emulator would save me some time, which would be good. But it would be good to have something where I could do digital signatures disconnected from the internet on a machine that had object capabilities all the way down. That would be really cool. Okay, so, the prototype system is based on post-market, which is Alpine Linux at the bottom. Okay, so it's not just OCAPS all the way to the bottom. Adds a new Alpine package, one of which does unspeakable things to the normal post-market OS package to replace SBIN in it with a syndicate replace. Interesting. So he let these guys figure out how to install Linux on a Unix kernel on a on a phone. And then he took over the root process. That's pretty cool.
So could we implement remote objects on that small talk? I mean,
oh, I assumed he already had, but maybe he hasn't. I guess Christine just said he's doing his own implementation of CapTP. CapTP isn't necessarily distributed. VATTP is the necessarily distributed layer. Yeah, I don't know where he is on that stuff. I think is there a web browser in here? This NLNet seems to fund some really interesting stuff. I run into these really obscure projects that are funded by NLNet. Obscure, but very cool projects. Anyway. Syndicate protocol. Okay, that might be. Yes, okay. So this looks just, yeah. So preserves is the marshalling technology, which is different in small ways from the agoric marshalling stuff, but it does have capability references. Or something? Yes. Okay.
I guess communicating the other phones is still a mystery to me.
Well, he's got TCP/IP here.
Interesting. There's just too much interesting stuff.
Right. Yeah, the thing that's novel about this syndicated stuff is the assert and retract stuff. Otherwise, it's the same as the CapTP, I think. And Christine is arguing that to put this assert and retract stuff on top, and I guess this guy, Tony, wants it to be the core layer. It looks like it's got prologue in the protocol. Binding, conjunction, negation, literal, compound. Oh, I see. It's got a attenuation sort of language. It's got a little bit of remote code. This is where we use Justin in the agoric architecture. Oh, they've got caveats like macaroons. Person to do the interesting membranes. Boy, that's tricky. If you have global namespaces, that's tricky. Transient references are more straightforward. Oh, here's something distantly related or mildly related. So Juno not that one. Do you know if you've heard of Juno, Jim? This Cosmos zone that uses Cosmosm smart contracts?
I don't really remember.
So the interesting thing about them to me is they have very well run community, and they have a ton of DAOs and stuff. They have DAO tools where you can just, push a button and get a new DAO and stuff. And so, they sort of walk the talk when it comes to distributed governance and stuff like that. So the question I had, I think I actually got as far as putting it in their Discord. Can we get unforgeable names, object capabilities, or something like that in there, like urefs in Casper? Because Casper does WebAssembly, and they have unforgeable names. They don't seem to use them very much, but yeah, 50 plus apps.
What Casper is that?
Casper Labs with Meta and
oh, right.
Where's the UREF stuff? Yeah. All right. Yeah, I probably should head out, but you should definitely check out Juno as far as actual community governance and that really, I need to set the do not disturb stuff so that stuff doesn't go into the recording notes to the video editor.
Yeah, I will copy the chat into the description, but you normally would index it, right?
Here's hoping, yeah, but maybe Thomas and I can do that. Thomas, go. He's my video editing resource. Anyway, good to see you.
Good to see you. No, I meant in the description. Edit it. I mean,
yeah,
the
timestamps and all that.
Right.
Yeah.
Okay. Good to see you, man.
Right.
And good stuff. Let's. I did copy the email on the Web3 stuff that you sent me. So that has another email address for him also.
Okay.
All right. Take it easy, man.
You too. Bye.
Bye-bye.